Welcome Tejal.
Thank you.
Tejal, I know for a long time, almost 10 years. One of the first person actually, when I came to US, we were studied together in Carnegie Mellon. After that, actually both of us went to Yahoo after that,
Mm-hmm.
and but after that, I went to a little startup called Hortonworks. Tejal picked up more and bigger companies with Twitter and now at Google after that.
Yeah.
Now she's working on Kubernetes, Kritis for specifically. So she's here to talk to us about Kubernetes infrastructure and an ecosystem. Welcome, Tejal. Get started.
Thank you. Thank you, Ashutosh. Good morning and good evening, wherever you are. Thank you for having me here. Today, I'll be talking a little bit about securing Kubernetes cluster with Istio and Kritis. Um, a quick introduction before we deep dive into the talk. Like Ashutosh mentioned, my name is Tejal. I work as a software engineer on Google Cloud Build Solutions team. So what we do is we try to come up with tools which are mostly open source to make Kubernetes application developers' life easier. So currently we're working on tools like a declarative CI pipeline for your K8 application. So it'll help you create complex pipelines like testing, integration, deployment, stages, etc. Using this project. We are also working on a tool called Scaffold, which helps you make it easier for locally developing your K8 application and then magically picking up your local changes and deploying it to wherever you would want to deploy it and then test it. And then the other project that I was working on was Kritis, which is kind of now in a maintenance phase because we have end up doing most of the feature development over there. Um, cool.
So before we jump into one quick thing, do you want to have questions people ask right away, or do you prefer to run through the meeting presentation first?
So first of all, I do want to apologize for my throat. So in case you guys, do not hear something, feel free to jump in and ask questions or ask me to repeat if you couldn't hear it. So feel free to interrupt me.
Okay.
We do have time for. I hopefully will have time for questions too at the end of the presentation.
Okay, so ask questions, folks, if you have. Mhm.
Cool. So before we get into what Istio is, I just wanted to focus about why do we need Istio. So with Kubernetes, containers, and Dockers being more popular, developers are now oriented towards writing microservices applications versus monolithic applications. So monitoring and securing monolithic application itself was a big task. And now with microservices, where there are more and more smaller applications that run on these things called containers in your cluster, it's becoming harder and harder to make sure that you provide observability and security for your apps. So it is not that you can do it. There are still ways to do it. You could use libraries or client side tools that help instrument your code. You could use third-party softwares like Vault, which helps you configure access policies for which particular application can users access and which are open to anyone else. But all of this means that you would have to end up writing code for this in your application. So your developers need to instrument your code. Your developers need to integrate with these third-party security providers to manage your secrets, to manage your access policies, and that's a lot of work. Istio was built with a concept in mind where users or application developers do not have to write a single line of code and just use to framework to provide observability, reliability, and security for your applications. And how does Istio does that? So Istio uses this concept of something called a service mesh. So mesh, as all of you know, is a network of wires and they are strongly connected. So, in the same way, service mesh is a network of services and they are connected to each other. They can communicate fast, amongst themselves. They are reliable. They know what service they are talking to. They can communicate securely, and all of this is with all for all the services within your cluster. So service mesh is this tightly coupled, fast, communicative services that run inside your cluster. And the way service mesh is implemented is using something called as sidecar proxies. So I'm not sure how many of you guys are familiar with the concept of sidecars. I've just put up there what sidecar is. So a sidecar, similar to a sidecar attached to a bike, is something that runs along your container. Um, so whenever you deploy to a service, the smallest, oops, sorry. Okay. So let me just pause this. Sorry. So sidecar, like I mentioned, are containers that run alongside your application code. So whenever you deploy a service, the smallest possible unit that you can deploy it on is a pod. And then one service can be deployed on multiple pods, but it's not the other way around. Like a particular pod cannot have multiple services running on it. So every application, along with your container that contains the main application logic, there's this sidecar that you can deploy. Sidecars are not new, and they are not only used in Istio. A lot of other users use sidecars to collect logs, to collect metrics, because both these containers are scheduled or run on the same pod. They can communicate with each other via storage. So if you see a spot spec, generally you end up mounting volumes. So your application can end up writing or streaming logs to a particular file in a storage volume, and then the sidecar container can grab those files and persist those to any backend that you would want to. Sidecars are mostly used for logging, and then you end up hooking that persistent storage to any other log analysis software that you would want to use. So Istio uses the same concept of sidecars, but not just these simple kind sidecars, which kind of read from whatever is watch for a particular storage volume, read and then do dump that data. But it has this intelligent sidecars which intercepts all the network traffic that comes in and out and goes out of your pod. So along with intercepting, it does more interesting things, which we'll talk about in the next slide. But this sidecar proxy is how Service Mesh enforces policies on your network, because they intercept the traffic calls, they make some intelligent decisions based upon the rules that have been configured, and then they decide whether this is allowed or not. They also collect metrics about how many requests they have seen, how many requests they have sent out, etc. And you get all your observability and security through these sidecar proxies.
Is that what is probably like in the network they call like a firewall? Or
So this is much more than firewall. Firewall can just say on and off, like, don't accept connections outside, or you could just do, but this can do much more, which is like intelligent routing. So it has this, so we'll look into it in the next slide, but you can say that, oh, deny all the traffic to this particular service, or you could say that I have two versions of the same service. I would want request with certain particular magic word in a header going to this service, to the version 1 of a service, and then with something else going to version 2. So you could do like canary deployments, you could do A/B testing with these routing rules.
So then in that case, it's not a sidecar, right? Then when it's doing the routing, it's like picking one of these services. So it's then not a sidecar for a service, but for all the services in that.
So we'll come to the Istio architecture in the next slide. There are two logical splits. One is the data plane, and sidecars is the data plane, because that's where all your data, because it runs with your with your application code, and application code is where all the data lies. And then there's the control plane, which you're talking about, which is like more intelligent, which has these different services and ways to implement policies. So let's go to that slide. So, like I mentioned, the data is where your application code, whatever is application is doing, and what it's processing. So, your application code and the proxy that sits along this application code is your data plane. That's where you collect and gather all the data, which is then used for anything you would want to do, like log analysis, metrics collections, monitoring, etc. A little note about the proxies. So henceforth, I might end up using envoy proxy or sidecar envoy as a term for proxy. So Istio uses envoy proxies as sidecar proxies. Envoy is another open source project which was created by Lyft. It's a very fast sidecar proxy implementation written in C++. It's very reliable. It can securely communicate between two sidecar proxies. So
So, and why is the implementation of sidecar concept?
yes, it's implementation. It's Istio uses Invoice right now. I don't think it uses anything else, but you can definitely write your own sidecar proxy implementation. Uh, but why would you? Because it's already open sourced. So you would use it's already out there and not reinvent the wheel. So proxies sit with your application, but they still need to be told what you would want to monitor, and how to, and what are your routing rules, or how to talk to each other. So there comes in the next aspect of the service mesh architecture, which is the control plane. So the control plane consists of three main components. The first one is the pilot. So the pilot is responsible for service discovery. What I mean by service discovery is that in microservice applications, when things are running on containers, the containers come in and go down. It could be because you end up having a scaling request. You end up either scaling up or scaling down, or there was a pod lifecycle event. For example, a pod just got killed or was just shut down. So service discovery is dynamic in Kubernetes world or in container world. So pilot is responsible of doing the service discovery for the NY proxy. And what I mean by that is that given routing rules and the service definition, it converts all this human configurable routing rules, which you would imagine would be in YAML, because that's how Kubernetes works. So these are all YAML configurations. So the pilot takes this YAML configuration and converts them into invoice proxy configurations. So it abstracts that layer of service discovery out. And hence, Istio can be plugged into different container orchestration modules, because then you have a pilot specific for every platform that you would want Istio to run on. So
When you say platform, you mean the application or the service you are trying to run in the pod?
By platform, I mean the container orchestration platform,
Oh,
like
I see.
Kubernetes or EK, Amazon's elastic computing, or anything else.
Okay.
So you would need to have your different pilot modules implemented that know how to take these configurations and convert them into the service discovery rules that are specific to the platform.
So technically, one can take these things out, can use outside of Kubernetes too?
Yes. So Istio can, I think there is Istio implementation for other platforms too.
I see. Okay.
Yeah.
There's certainly Envoy for other platforms, and I believe it can be used to integrate, like bare metal VMs, things like that, into the same mesh.
Yes, there are. Yeah. Okay. So pilots, I mean,
so that control plane API is like one monolithic app that does this, or like is it like replicated, or like who controls that control plane app?
So the control plane API, whenever you install Istio, you can configure which components you would want. Like Pilot and Citadel is on by default. you can say that I don't want to use Mixer at all, which means that you would lose monitoring, logging. We'll get into that
So I think the
next.
question was: are these like also deployed as containers in that?
Yes,
where
they
do
are. They are services that run inside your cluster when you install Kritis. You can also specify but they are just single
But what?
instances of
Yeah.
services.
So what happens if that thing fails?
Oh, because it's a service, when a pod fails, the pod running that service fails, then Istio is going to detect that. Kubernetes
True.
detects that. The API server, Kubernetes API server detects that and reschedules it.
But like in the meantime, when it is rebooting,
Yeah.
everything works fine, or like is there like a black hole in there that when it is rebooting, then
Mhm.
those pods and the proxy they lose
Well, the
track
proxies
of each
do
other?
right. The proxies do have a local cache of data, but the service mesh might go down for a second,
Okay,
but they
so-
can recover.
So if that thing fails, the mesh is kind of like not really working.
They do have local caches, the proxies.
So the mesh would actually need to be stable in that.
Yes.
So you couldn't add services or remove pods,
Yes.
right? But
But it'll be functional to the state that it was last known.
Yeah.
Does that make
See.
sense?
And the service discovery, is it like backed by Zookeeper Raft kind of thing? Or like how is
No,
that?
it's all based on the platform.
Okay.
in
So-
Kubernetes DNS.
Yes. So in case of Kubernetes, it's DNS.
Okay.
So it all depends on what the platform relies on for service discovery.
See. And like for some, I mean, I'm not sure if this question makes sense, but can you like replicate that control plane
So
API
usually
and
the
have
way
a hot and a cold one that does switch?
I don't think so, but I might have to look into it because
Okay.
usually the API server is a single instance. And this is something like a controller or an API server, so it's a single instance running.
Good.
Yeah. Okay.
So I didn't get what the mixer does. Sorry.
Yes, so I'm going to get into that
Oh, okay.
next. But before that, so all of these, like I mentioned, the routing rules, they are distributed to the proxies, so the proxies have the same information.
Is going a little bit on what you just asked, right? So there's one control plane for a whole Kubernetes cluster. Could I actually carve out a subgroup saying this set of services is actually controlled by Istio, others are not, and they're actually having the
So
control plane.
right. So I think you can deploy rules based on named services, but there would be a control plane for the whole cluster, and then you can say that, oh, I would want Istio to be disabled in a particular namespace. So the way Istio works is that only pods which have proxies injected in those are controlled by Istio. If you have a pod and you say that, and that is controlled by a simple label, you could have like a label on a pod saying that Istio injection enabled true, which means that now this pod runs a proxy along with the application code and is controlled and managed by Istio. But you can add rules which says that do not enable the label in this namespace, or always enable it in this namespace. So you can do all that kind of stuff. And then you can also have routing rules enabled per namespace or cluster wide. It depends upon the routing rule. Certain rules can be enabled cluster wide. Certain rules cannot be. Like, for example, TLS is something which is enabled cluster wide. So you could say either the communications are encrypted or not encrypted cluster wide. But you could say based on namespaces that I would want to deny services in this namespaces. I would want to deny HTTP services or HTTP. I would only want to allow HTTPS services.
Actually, namespacing came only in this recent version of ISTU. Earlier, it was like for all single control plane for all the pods.
Yeah. But no, the pods, they still were controlled by labels, and you could do Istio inject command, which would end up injecting the sidecar proxies. So you can control what proxies, what pods you would want to be part of Istio control and monitored stuff. Cool. So we'll now go to the next component, which is the mixer. So the mixer is the main component which communicates with the proxies back and forth and enforces policies. So whenever incoming request comes into a pod, the proxy intercepts it and it sends that request to the mixer. And the mixer has this adapter functionality wherein you can plug in different mod backend systems. For example, you could plug in the auditing backend system, which would just take the request and audit it. You could plug in Prometheus in this, which would mean that the request data is sent to the Prometheus now, and you could get stats and observability out of it. You could also plug in logging stack driver, which is a real-time log analysis product that Google offers. So you could plug in a stack driver backend module to the mixer. So every request that comes into the mixer, you can configure the requests, you can configure the mixer to route those requests to certain components, and then you achieve logging, auditing, persistence of your log, etc., using the mixer.
So every request that hits a pod, it bounces back to the mixer.
Yes.
How
Every
does that scale?
incoming so the proxies are smart level 7 proxies, which means that they can intercept all the network data, and then they can reroute it, split it, or duplicate it and send a request to.
No, but then does it understand the protocol? Does it can it only support the HTTP or
Yes,
can
it can.
support
It is application level layer proxy, so it can support gRPC, it can support HTTPS, and it can support HTTP.
But like how you can scale that up? Like if you have like I don't know, like thousands of requests per pod, if you have thousands of pods, like
It's only metrics are being sent to the mixer. It's not all the actual data.
Yes, so it is. I was going to talk about it next, which is like the proxy intercepts the request, extracts the attributes from the request, which could be like the request size, the request time, the request end result code, and then it just sends all these attributes. And you can configure which attributes you would want to send also.
So it's not waiting for a response of the mixer?
It does for precondition checks. For example, a request comes in and you say that I would want to accept only HTTPS requests, then it would, or I would want, or a routing rule is placed where it says that deny all incoming requests to this service, then it would do the precondition check in the mixer. So it is sent to do a precondition check, and based upon whether it's allowed or not, it'll send a response out.
So the mixer actually in this scenario could become a bottleneck if there are thousands of pods and they're actually also waiting for the one mixer to come back with a policy decision on if this is okay or not okay.
Well, I'm not exactly sure how it scales, but I
or is
think
it the case that mixer runs in the sidecar with the
no,
proxy?
it's
The
a part
control
of a
plane.
control plane because it talks to other backend infrastructures. I would have to look back and see if it's like if it runs multiple instances of the mixer or it's just single instance of the mixer. Maybe someone who knows how to configure mixers might be able to answer that.
Is this on a per connection basis or is it on a is it set up for a while? Does this happen for every connection?
It happens for every incoming request to a pod.
Okay.
Yeah.
And I guess you can say that like check the I don't know like the JSON request if it has this field or not or.
Yes. Well,
So-
not those kind of complex. I mean, I'm sure you could have a backend module which applies a policy that I would want JSON to have.
It's a protocol
Yeah.
specific. So in HTTP, you can read headers, for example, and do some policy based on
I
that.
think it is definitely heavyweight. I mean, anyway.
Yeah, it is heavyweight, but that's why it's implemented in C++ to have like this fast, reliable communication mesh. And the service mesh is supposed to be fast and reliable for that same reason.
But
Yeah.
you actually said the mixer is optional, right? So I could actually run just with a pilot in the Citadel.
Yes.
Would I lose complete the monitoring capabilities for
Yes,
Istio
you
in that
would,
case?
because then since the mixture is disabled, you would not end up sending intercepting the proxies and send metrics to, or even if you have mixer enabled but you do not have any backend like Prometheus or
It could be something like a full model, right? So if I'm only interested in monitoring while Grafana is open or something like that, I could actually say I pull the information from the different proxies instead of having them constantly with every request be pushed to a mixer.
I'm not sure about that.
Okay.
Yeah. So similarly, the mixer also records the response. So if there was a 400 response, or if there was something else that happened, it records the response. So you could do so that's where stack driver monitoring comes into picture, where you could get real time analysis of what requests came in and what was the responses that your services sent out. Any more questions on mixer?
No, but you actually said it's protocol specific. So I would, for example, assume that Swift does not support. Is it something that we could actually plug in there? Or if you say if there's
so that would be something that you would want to have to contribute upstream to Istio.
Okay.
But the documentation says that it supports GPRC.
So it's not really pluggable, but we could extend Istio for that.
Yeah. You could add support in Istio to understand the thrift protocol. Cool. So the next one is Citadel or Istio Auth. So the Istio Auth is responsible for encrypting the traffic. So you would want to protect your services from the man-in-the-middle attack. You would not want to send just raw data over, because these proxies, which I forgot to mention over here, they can talk to each other. They can discover each other. If the traffic is not encrypted, if you just send raw bytes, that any other service malicious app can come into your cluster and monitor those, which you don't want. So Citadel is responsible for encrypting data that is sent within the service mesh. It also handles TLS. So if you want to set up a service which does end up doing a TLS handshakes, and there's a lot of setup that you need to do. You need to create certs in your Kubernetes cluster. You need to install them. You need to create secrets. Then you need to volume mount those secrets as volumes onto your service spec. So there's a bunch of stuff that you need to do, which you end up handing over to Citadel. So make sure that the secrets are created. They are also auto-rotated. They have an expiry, so you're not using the same secret over and over again, or same secret forever, because it might just get compromised. It does all of that, and then it uses Mixer for any access controls that you would want to specify. Say, for example, you have a user profile page in, so you could say that only users can access the profile page. But a product page can be accessed by anything, because it just contains information about your product. So you could provide all those kind of access policies, and these are all again implemented via Mixer, because every request that comes in, it extracts the attributes and then it sends it over to Mixers, and then it checks if your backend can check if a particular user is if it has a user ID associated in the header, and then make sure that it can access that page.
And I assume I could also have something like more static rules, which service is actually allowed to talk to which other service, right? So that I say this is a subservice. It's only supposed to be getting requests from one particular.
Yes, you could create these routing rules where a service A cannot talk to service B, or a service A can talk to these services. So those are all routing rules. So. But yes, and then you can create service account roles. For example, you create a secret with a service account and create a service account which has that secret. Then you could say that only these service accounts can access a particular service. So for example, if you have a admin role, then only admins can access this particular page of my product, things like that.
So how do you get your, like, let's say, TLS certificates and stuff to the Citadel itself?
It is all built in. You don't have to do anything. You just have to write they generate it.
If I have my own org, I would like to use my
No,
own
but
as a
that's
root,
for
right?
pod communication, right?
It's for
That's not
services, not for
external
users.
communication. This is
Yes.
for just cluster internal communication.
Yeah, for external communications, then you do have to set up auth, right?
I see.
You do have to create your own secret and make sure, and then you have a public and private key, and then you give out your public key and make sure that users are using that to whatever decrypt whatever you end up sending it over. But
I see.
within the service mesh, TLS takes care of it. Or if you have like a backend and front end on your cluster and you would want them to communicate securely, the Citadel will take care of it. But an external user talking to your front end, you still have to provide that part. Okay. So any more question on Istio before we jump into Kritis?
So you said one of the implementation is Envoy. What are the others? Interested.
I don't know that,
Yeah.
but I don't think
So
there's-
that bottom rectangle and the proxy one, those are like the Envoy, and all
the
the rest is.
proxies are Envoy, and all of these are
Only the pink thing is Envoy.
Oh,
yeah,
so
only the pink thing.
what is the bottom thing then?
Oh, these are platform-specific implementations.
Oh, so every platform will have its own pilot and mixer.
Yeah,
and-
because they are and then the mixer probably doesn't need to be very platform. It still needs to be platform-specific, yes. But it's pluggable, so it can talk to other backends.
Have there been any measurements on the overhead of this in latency, but also I assume it's using IP tables on the proxy and so on.
They say it's pretty
Sounds really good.
fast, but I don't think I have the metrics, but maybe you can look through the docs. They're pretty open. You can get into Mixer. There's like a huge section on mixers itself. Like it could be a presentation of its own.
But this is something that you get out of the cloud provider, right? Like you don't even get to choose your own mixer, I guess. Like
Oh, so Mixer is kind of a module, right? And or a spec, and you need to implement that with in your cloud provider. Does that make sense?
I see.
No, so for example, in EKS, so Istio, for example, you have to set up your services with Istio yourself. So these are all containers, so all images are available, but you configure how you want to run your services and enable Istio in them.
Yeah, and then for Kubernetes,
Platform
there's-
EKS only is providing the Kubernetes API server.
Oh, EK itself
EKS.
provides. Okay.
EKS just provides the Kubernetes API server, right? I mean, Istio and those things, you configure your app to run with it.
Yeah, it can run with your Kube server.
Yeah.
Yeah, it can talk to a Kube API server. There is a Helm release, like you just install it into your Kube server, and it knows. Okay, great. So we talked about Istio and what Istio can do. It can secure and monitor the services on your application, on your cluster. But when you write application codes, you don't write from scratch. You end up like using third-party software, right? For example, if it's a Go app, then you end up probably pulling in the runtime image provided by, say, Google or any other trusted source that you think is trusted. And then write your application on top of that. So how do you make sure that all these third-party images that you're pulling into your app are secure or they don't contain any vulnerability? So Kritis is a tool which would help you make sure that you can only install images that are verified by your system. It could be your CI/CD system, or it could be some manual person who just says that, oh, this is a good image, use this, and it's allowed in my production cluster. It can also monitor all the pods that are running in your cluster and figure out which of these pods are running images that contain really high security vulnerability, because vulnerabilities are discovered every now and then, and at the time that you use the image it wasn't there, but then later someone found it and now your application is vulnerable because it's using that image. So how do you gate those kind of situations? So this is where Kritis comes into picture. So Kritis is a policy engine which tests few policies that you declare at deploy time. So this is even before your application is deployed. Whenever you send a request to deploy your application, it checks if these policies are met or not. And if the policies are met, then it allows the application inside your cluster. If it not, it just denies it and it just says you cannot run this application in this cluster. Period.
So it runs in the API server or where?
So we'll take a look in the components. So API server, I think Kubernetes 1.9 version and higher, open sourced or had this concept of validating webhooks, where API server itself does a lot of validation for an incoming request. But if you need to have some custom validation, you could provide, it allows you to have these validating webhooks, which can listen into the request and do your own custom validation and decide whether this is allowed or not. So it uses that part.
So Kritis is basically a module which loads up in the API server.
Yes, it is. It's a controller, you could say. It's another admission controller along with the basic admission controller that kubeAPI has. So right now, Kritis can provide vulnerability scanning, meaning that it continuously scans images that are deployed in your network, in your cluster for vulnerabilities. It could also verify build provenance, meaning that where did this image come from? Is it signed by a signing authority that I trust? If it is not signed, then it just marks it so that cluster admins can look at all these applications or these pods that are running these insecure code or not verified code.
So, image you're referring to Docker?
A container
image?
image, a Docker image, a container
Okay.
image. Yeah.
Is there any other thing besides the Docker? Very
Google
little bit
Registry, Google Cloud Registry is another. So Docker, just a Docker repository hosts images, right? So Google Cloud Container Registry is another place where you could host your images.
Okay, but it's still like it is a Docker image.
Yes, it is
Yeah.
a Docker image. Yeah, you mean like a
Like it is not like a VM image, like I don't know, like a box or
what? Sorry.
like a bare like VM, like I don't know,
No, these are not
Ubuntu image
containers.
or
Yeah.
whatever it is.
No.
So for so then how does it? How can we make use of it? Because it depends on the hosting
Correct.
service, right?
We will look into it next.
Okay.
So you guys are always asking questions for the next slide. So should show the next slide first. So
Should we-
like Ashutosh mentioned, like how do we support images which are hosted on different registries? So we started with this project called Graphius, which is an open API metadata spec for images. So it extracts all the information and kind of stores all the metadata for image. The metadata may include like what are the packages in this image, what versions they are. So if you pick a Debian package, the way it is implemented is we just look at var stats db file, which contains a list of all the packages. And for pip, we look at the pip install files that should be placed in certain directories, and we index all those files, and then we store the metadata for those files. So that's how we end up indexing the packages and the versions for that are installed in the particular image. Along with that, it also contains metadata specific to where the image came from. So if you're using, I don't know, a lot of people end up using Cloud Build, which is another provision of Google, where your image is built in the cloud, in the Google's cloud. So if you configure Cloud Build, then it tells you this image came from a Cloud Build source. If it's not that, then you can manually say that I built this image from my CI/CD system, and you can add that metadata and attach it to the image. So the Graphius is an open API spec. We currently use it mostly for vulnerability data, and along with that, we also use it to assert source of this particular image. So that's the only two things.
So this is a little bit like the manifest, right? So this is stored with the image or as part of the image now, or
it is stored in SpannerDB right now. You can install Graphius in your cluster, which would mean it will create a SpannerDB instance in your cluster, and all
SpannerDB?
Yeah, it's another
Like
database.
Spanner?
Yes, Spanner.
better.
Oh, like the
No, like the Spanner database that Google uses? or-
yes. Yes. So right now we use SpannerDB to store all this data.
So you have the image and then you have this metadata separately in the spanner, and then you
Yes.
identify with some identifier.
Yes, you can install SpannerDB. You can install Graphis in your cluster, and that'll create an instance of SpannerDB. You can expose it to other clusters. You can share it between your clusters. But whatever image you're using in your cluster, it gets indexed, and all the information for that image gets stored in the SpannerDB. But right now, it's not there yet. So it's we're using the internal Google Container Registry and internal Google Container Analysis API to use Kritis, which is one of the main reasons why it is not well used, because you have to rely on Google products. But we are getting there. People are working on making Graphis installable in your cluster, which it already can, but it should also index all the information and store that in the DB, because once it is available, once you have it on-prem, then you can write any policies. You can store any metadata that you would want to, and enforce those policies at deploy time. So that's the goal, the end goal of Graphis and Kritis.
So the Google GKS already supports Kritis?
We do.
Okay.
We have an internal product offering called BinRC, which you can just enable on the clusters that you create, and it uses the container registry. And your images need to be hosted on Google Container Registry so that we can index them, and we store it internally on Google's internal.
So how do you validate actually that there's no malware in my image? I mean, if I can create my image on your cloud, right? It's nice that you can actually create a manifest on it and store it in Spanner, but somebody actually has to look into the image really to figure out if this is a
Yes.
trustworthy image or not. Just because I can create it on your cloud doesn't
No.
make it trustworthy.
No, that is why you define a policy saying that I do not want images which have a vulnerability, and then we'll go fetch that data. And if it does have a vulnerability, we'll deny it.
I guess the question is, how do you look inside the container to know there is a vulnerability?
Oh, because this is all stored. The data, the image metadata is stored in the SpannerDB. We query the DB now. Does that make sense?
I think they're just going against the list of known CVEs. and stuff.
Oh, the CVEs.
Yeah, I don't think
yes,
they're
yes, yes.
inspecting your code and saying, "Oh, that looks evil."
But that's
No,
my
no,
point,
no.
right? I mean, it's nice to find vulnerability against Postgres that is part in an image or something like that, and it has a known issue, right?
Yes.
And then you could identify all the images with this known issue, right?
So
If
is
I
it-
actually put in my own code into my image,
No,
Yeah,
no,
then
no, no.
nobody knows
Well,
what
there
you
are-
put into that.
Be it
and
on
if it's
your own head
trustworthy.
then, right? Until somebody finds that
Yeah.
you've got a vulnerability.
But there are certain products like Twistlock, which are private products, like you have to pay for them, but you can say that my application can only do these calls. And if it does something other than that, you can whitelist the system calls. And if it does something that's not whitelisted, it gives you an alert. You can look at that.
So then you basically go look at the versions, for example, of those.
I don't know how they work. I met them.
No,
and
yeah, the Kritis. The
Oh, the Kritis?
yeah.
So we have integration with Claire, which publishes vulnerability data.
Yeah, so you know, let's say Postgres 9.4 is a vulnerability.
Right.
Now in my container image, then you go and look at the version string of my Postgres.
Yes, we do make sure if you have that version. We only alert you if the fix is available, because if there is no fix available, there is nothing to do. You just know that there is a vulnerability. So there are different levels of alerts that you could set.
Is there a reverse way for me to actually figure out what are trusted images right now? For example, if I write an application that needs an MariaDB container, right?
Mhm.
I want to make sure that I take the right container image, which is not blacklisted, but
Yeah.
something that I could say, show me whitelisted containers.
There's no whitelisted containers, but you could say that run Kritis, we have like a process that you could just run to inspect a particular pod spec and say whether, and kind of it tells you whether this pod will be accepted or rejected. Like you don't have to find it out at deploy time.
So
Would
it
it
is
tell
one-
me which one would be accepted, right? I mean, I could try one pod after another one, or one image after another one.
Yeah,
The Kritis blessed the images in GCR.
yeah.
Is the ask.
Well, no, it does not. You cannot say, well, in GCR, we have a fancy UI where if you host your image, it tells you if there are any vulnerabilities or not. If there is there a backend for it? No, it just indexes all the SpannerDB, and there's no way to query the entire spanner DB to know what are the list of images. But if you want to use a particular image, you can click on that image, and there's a tab which gives you information on vulnerabilities, and you can see if those are the things that you want or not, and then you can decide if you would want to use it or not. Yeah, but querying the whole DB to figure out, I don't think.
No, my point was different one. For example, let's assume our product is requiring an Alpine image with Postgres, right? Let's say for Metastore. Right?
Yeah.
We want to make sure that we pick the image which is not blacklisted. Right?
Yeah.
There are multiple different versions out there, and maybe one of the older versions which we use is blacklisted due to an vulnerability, right?
Yeah.
So I would actually need an interface to go through my currently selected list of images to make sure that I only
you can write a script. G-Cloud kind of has that information. You could say G-Cloud, describe this image, minus, give me vulnerability info. But you would have to provide it with the list. It only works per image. So you'll have to like a shell script, which gives you a list of images and then run G-Cloud over it. You could get that information. But there's no way to like...
So Kritis is only for G-Cloud so far?
Yes, only GCR hosted ones, because metadata is not any GraphQL metadata is not kind of installable on other clusters right now. Like it doesn't integrate with Claire to find out the vulnerabilities. You can boot your DB with like whatever you know, but it doesn't have that automatic injection going on right now, so it's not kind of much use.
Does other cloud provider they have their own version of this, or
can you repeat
like
that?
the other cloud provider, do they have their own version of this?
No, but they would want GraphQL to be, if they have GraphQL, then if GraphQL works, then yes. But right now, no. No other registries have that yet. Okay, so the way policies are enforced is using custom resources. Are you guys familiar with custom resources in Kubernetes?
You can explain it.
Okay,
I'm so outdated.
Resource is resource is like a collection of Kubernetes objects. So what I mean by that is, like, you know about pods, right? Pods is a resource, and it's a collection of pod-like objects. And then it adheres to a particular API. Now, Kubernetes has this flexibility when you can define your own custom object. So you can create something like foo and say that foo can have these fields. Example, it has a field called what is the name, then something like echo or message, and then Kubernetes, and you can configure these foo objects. You can create instances of these foo objects and deploy them in your cluster. It could be anything. It doesn't have to have a container image to it. It could be just any blob of data. And then you can use kube control to like create these foo-like objects, list them, delete them, all those kind of things that you do with built-in objects. So custom resources, you can think of it as like an extension of Kubernetes, and it knows how to create custom objects, and you can interact with these custom objects. Well, once you take a look at like how a custom object looks like, it'll be a bit easier. But think of it as a way to like create your own custom objects that you could interact with using kube control.
Yeah. Some object is just like a pod, but it has some.
It adheres
APIs
to
that
API, like it knows it'll get, list, whatever.
Okay.
It also has like a namespace associated with it. It has a name associated with it.
So
It has a version associated.
logical unit that lives in the cluster.
Yes. Then we talked about validating admission webhook, which you can kind of configure. You could say it's just an HTTP endpoint. All the admission requests that come into the cluster are also sent to this admission webhook, and then you can write your own custom logic to either deny or accept that request. And then finally, CVEs, which is the common vulnerabilities and exposures. I think we are using Claire to get all the CVEs, known CVEs. So I just wanted to tell you about what that stands for. So now let's look at what actually Kritis does. So whenever you type kube control, create a pod or a deployment, what happens under the hood is that an admission request is sent to a kube API server. The kube API server validates it, makes sure that it's okay. And then if you have any admission webhooks configured in your cluster, then it sends that admission request as is to the admission webhook. This admission request contains a pod spec, and then the pod spec contains the list of containers that you would want to run along with the images that you would want to run in this pod. So the admission webhook then ends up reviewing this process, this spec. So like I mentioned, excuse me, we rely on the container analysis API, meaning that all your images need to be hosted in GCR right now, and you need to have container analysis API enabled on those images so that we index them and store the metadata internally. So we get the vulnerability info and the attestations for that image. In future, this entire pink thing will be replaced by something on-perm that you would end up installing using Kritis. So this is the custom resource which defines the policy. You can define policies per namespace. So you could say, this is the policy. I can allow critical images, critical vulnerabilities in my test cluster or my test namespace, but I cannot allow it in prod namespace. So you can define these at namespace levels. You can also define sources. What are your trusted sources at namespace levels? You can say, I trust only images signed by this particular signing authority in prod, and I don't care about what you install and test. So you could do that too. So the reviewer is going to then review the request for every validator. Right now, we just have the image security and the build provenance validator. But in future, we want to make it plug and play so that you can write your own custom validator controllers and your own custom resource. We're not there yet, but that's where we would want to be. So once the image is, it either accepts or admits it. So if it's denied, then it goes out of the pod, nothing happens. If it is admitted, then we attest it, saying that, hey, at this particular time, this particular container was valid. It passed all the security checks. Please admit it. And then the attester signs it using a key that you configure in your cluster. And now the pod is admitted in your cluster. So we will take a look why this attestation is required in the next slide. But for now, think it's a part of a flow. Like I mentioned, vulnerabilities keep getting discovered. So you would want to know if you have any pods that are running in your cluster which do not adhere to the policies that you have specified. So for that, we have a background job which runs every hour, which looks at all the pods that are there in your network, in your cluster. We run this every hour. Obviously, it's configurable. The reason why I run it every hour is because we fetch new metadata, new vulnerability data every hour. So that's why it's per hour. So the background job also goes to the same flow, but it validates it. It fetches the custom data of metadata. But in this case, it cannot deny a pod because the pod is already running. It cannot kill it because we don't know what your application is running, and maybe it's the only instance that it's running, and you don't want your application to die. So what we do is we add a label saying that this pod is out of policy. And now cluster admins can actually query based on that label. So you could just say kubectl get pods -- label name equal to whatever invalid policy, and then it'll show you all the pods on the console. So this is more like a way to like look at what is out of policy right now. So this is the admission flow. Now, what happens when a pod dies? So say you have a pod running, it dies. So Kube's API server knows that it needs to start up this pod again on some other machine. So it again sends an admission request. Now, note that this admission request is same as the admission request that you would end up getting when you create a new pod. So there is no difference whether a pod was restarted or it was a new creation. So that is the reason where that is a yeah. So that's why we kind of have these attestations which come into picture, which are very important because now when we review, we fetch the metadata, but we end up seeing that this pod is a valid attestation, meaning that this application was gated, was checked for all policies sometime in past. It might be out of policy right now, but because it's a restart activity, we don't know if this is a single instance or it's a multiple instance. We do not want to deny something that was already admitted, so that is the reason we pass it on. But if it does not meet the policy, we again add the invalid policy label. So we do the policy checks, but we don't deny it in case it has already signed, already attested kind of, or already verified kind of attestation. Does that make sense?
I guess you can configure it to feel.
No, right now we don't allow it to be configurable, but we can in future. It would need some code changes there.
Right.
Yeah, it was with a goal saying that if something is allowed, it should never be denied in future, unless someone goes and manually turns it. Or as a cluster admin, you can go and delete attestation. So you could tell your Graphics metadata API saying that don't trust these attestations anymore, and it'll delete those, or
Right.
it won't matter basically because they're not trusted anymore. So next slide is this custom resource object. Maybe so you must have seen how a pod spec looks like, right? So in this case, API version is the Kritis API. Your kind usually is pod or deployment or service. But now I've created this new kind. This is my custom resource, which is called image security policy. The metadata has a name thing, which is like name. It could be anything, and then the spec. So Kritis allows you to whitelist certain images, meaning that these images are always allowed. Don't do any checks for them. And then it allows you to specify the package vulnerability requirement, saying that only allow up to high severities in my images. So if anything is critical, it gets rejected. We also allow you to whitelist CVEs because there are some vulnerabilities which are there, which are discovered. No one is working on them. They're never fixed. I don't think they will get fixed because they don't matter that much. So you can whitelist CVs saying that, oh, this CV is fine. We know about it. We know people are working on it or people are not working on it. It's okay to have this vulnerability. Any questions on the custom resource? Doesn't make it more clear? So now you can write this YAML, you can install this object, you can get this object, and then you can have a controller or the cube, your validating webhook actually can read this and read the spec and kind of make sense and validate all the information.
So I guess when you update the spec, do you bump the version or like how does
Yes, it all depends on how you would want it, like developer guidelines that you follow, but we end up updating a valid same kind of two different versions could could have different fields. So when you list, when you can configure, when you ask for resources, you say that give me pods of this API version. So there's always a API version associated with the get command. So you could do that. I mean, not the kubectl get. I'm talking about the API server, the way it watches for resources. This is the attestation authority. So if you would want to sign images, then you need to create an attestation authority. Signing images means some cluster admin or some CI, the end of your CI/CD pipeline, you have like a signing step that this image was built by my CI/CD pipeline, and now I want to sign it, say, because now it's okay to use it production. So all you need to do is you need to create a Kubernetes secret. You need to first create a PGP key value pair, private and public key, and load that as a Kubernetes secret using the kubectl create secret command. And then you end up adding the public key. Oops. You end up adding the public key over here. So your CI/CD pipeline ends up signing the image using the private key, and we that is stored in the metadata. We fetch the metadata, decode the key based on this public key, and if the data matches, then we allow it, which means that it has a valid signature. So it's a basic signing process that we end up doing on the Kritis side.
I'm very ignorant in Kubernetes. So how do you make sure that there is only one guy who can put the public key or like modify it or like how to make
So
sure that
anyone
nobody can mess
can-
around with this key?
Anyone who has a cluster admin, so you can create like a service account and create a server, bind that to a service role, and then you can say only cluster admins can create or edit these secrets in this namespace.
And you do like kind of like logging, who did change it and who?
No, there is no logging for that. Like Kubernetes, you can edit objects on the fly.
Okay.
Yeah.
So if someone changes the key, then you can't say who.
So there'll
It's just
be
like
yes,
as an
but
admin.
it won't affect the Kritis because you can define multiple attestation authorities. So if you create a new attestation authority, you can any one of them should match. Does that make sense? So that's something where what happens when someone deletes or copies your secret, or it's the same problem. You would end up having a DOS for a certain while until someone configures a new secret. Yeah. Cool. With that, we are already over time. Sorry about that. Come to the end of the talk. So just a summary of like what Kritis can do and then what Istio can do. Kritis can help you secure your production environment, your production cluster based on third-party software and images that are and packages that are used in your application. While as Istio can monitor your application and secure at the application layer. And then with Kritis, we are not yet there, but we would want to make it pluggable so that you can bring your own policy code and then just run it with Kritis, and you can create your own policy. Cool. I think that is it. Any questions?
Questions online?
Yeah, I have a quick question. So I've seen other projects in this space as well. I think one is called Open Broker API or something. Sorry, Open Policy Engine or something.
Yes.
How do you guys compare with the other projects?
So Kritis, like I mentioned, uses Open Policy Engine doesn't yet use the Graphius metadata API to index the package information. So that is one thing that we are doing different.
The
But
goals are the same.
the goals are the same. You can define policies and then distribute and then kind of use the admission webhook to verify these policies.
Who is behind the open policy?
Is it Red Hat? I think it's Red Hat. We were thinking of doing collaboration with them on this too.
Mhm.
Yeah, it is Red Hat.
All right. Yeah. Thank you, sir. And sorry, I may have missed the starting. Is the goal of Kritis to be kind of like cloud agnostic, or is it kind of like gonna be always focused on the Google?
Right now, it's focused on Kubernetes. There is
It's
no.
actually cloud, like focus on Google Cloud.
Oh, it is focused on Google Cloud for now, yes. But it is supposed to be cloud agnostic, and that is why it's very important for Graphius, which is the open API spec, to be able to be installed in other non-GKE clouds. So we're working with them to make that happen, and once they make that happen, then we can make Kritis cloud agnostic.
All right, cool. Thank you.
Cool.
Right. Then
I actually have a question. Hello.
Yes.
Prashant.
Yeah, I have a question regarding Istio. So, can you use Istio for discovering services between a cluster that is not running Kubernetes versus services that are running within Kubernetes? Like, can Istio act as a service discovery layer between a Kubernetes and a non-Kubernetes cluster?
Oh, so you have like two different clusters. So service mesh is within a cluster, so you cannot have service mesh services talking amongst a cluster. Service mesh cannot be between two clusters. Does that make sense? Does that answer your question?
No, I'm asking about the service discovery part. Can Istio provide a service discovery layer for services?
Yes. So you would have to implement the pilot module for it. I'm not sure if
Okay.
it's already out there.
So
It could be.
once we implement pilot, then I can tell it. I can tell it the rules on how to discover from
Yes, you
outside
need
of
to do the
Kubernetes.
mapping for like
I see.
the
For example, I can say
configuration.
that look in my Zookeeper cluster for all the addresses and allow these.
Yes,
services.
and then convert those into the Envoy proxy configurations.
Yes, because I've seen examples where people have had bare metal databases. They've had to install the Envoy proxy themselves. It's a bit tricky to make it talk to Citadel for MTLS certs and things, but it can be done, yes.
Yes, there is no information out there. You just have to
Right.
write it, do it.
Okay. All right.
Cool.
If there are no more questions, then we'll stop now. Thanks, guys.
Thank you.
Thanks, Tejal.
Yeah.